Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, I'm Dr. Joseph or Mr. Explicit. Please, as you watch this video, endeavor to subscribe, like, share, and comment so that when I upload any content, you'll be notified by YouTube. And secondly, if you are preparing for 2024 UTME, Post-UTME, WAEC, NECO, GCE, NAPTEP, and nursing examinations, endeavor to chat me up on 091 60 11 53 75. I take it again, 091 60 11 53 75. Do not forget we are taking physics, chemistry, mathematics, and biology. And of course, I promise that I'll be starting from scratch. That is introduction to every science subject. Introduction to physics, chemistry, biology, and what? Mathematics. In physics, we have treated fundamental and derived quantities. And of course, we've also taken what? Dimension, alright? Today's topic is work, energy, and what? Power. Now, the word work is not new to us as science students. Work means the product of force and what? Distance. It means the product of force and distance, and of course, it is a scalar quantity. Work is a scalar quantity. Take note of that. In the sense that it has magnitude or size, but no direction. Okay, unlike vector quantities, which are quantities that have both magnitude or size and what? Direction. Now, how is work measured? Work is measured in joules. Alright, if I don't use the word measured, I'll say SI units. The unit of work is what? Joules. And of course, it is a scalar quantity. Please, work is said to be done. Work is said to be done when a force moves an object. Work is said to be done when a force moves an object through a direction, alright, or through a distance. Please, work is said to be done when an object moves through a distance, in the direction of the force. Jump past question. Which of these is correct when work is said to be done? Work is said to be done when a force moves an object through a distance in the direction of the force. Or I'll say work is said to be done when an object moves through a distance in the direction of the force. Alright, so please take note of that. As I said, it is a scalar quantity. It's measured in what? Joules. Alright, but the work done in an elastic material or a spring, the work done in an elastic material on a spring is given as half Fe or half Ke squared. Alright, half Fe or half Ke squared. F is force and E is what? Extension. K means the force constant. Force what? Constant. That is what K is. Force constant is K, and of course extension is what? E. Taking that work is a scalar quantity and it is measured in joules. Work is said to be done when an object moves through a distance in the direction of the force. Please take note of that. It is very important. I'm looking at my board wiper. Please excuse me. Alright, since we've established that already, let's take the next one, energy. What is the meaning of energy? Energy can be defined as the ability or the capacity to do work. Alright, in other words, I would say it is the ability of a body to do work. That is what? Energy. Energy can be defined as the ability to do work, or it is the ability of a body to do work. It is given as force times distance. Energy is also a scalar quantity, irrespective of the type of energy. Alright, potential energy, kinetic energy are all scalar quantities. Now, what is the SI unit of energy? Energy has its SI unit as what? Joules. It has its SI unit as joules. Please, I would have illustrated something before doing this. Let me put it that way. I forget. Alright, you agree with me that this place is the y-axis. Is the y-axis, and of course it is a vertical direction. Alright, and here is what? The horizontal direction. Alright, and here is what? The x-axis. X what? Axis, and this point what? 0. Now, the work done, alright, work done around the y-axis. Work done around the y-axis. Alright, please, y-axis, which is a vertical direction, it is given as sine theta, that is the vertical direction, which is the y-axis. But the x-axis, which is horizontal direction, is given as what? Cos theta. Alright? Normally, what is work done? What is work? Work is force times what? Distance. Now, that is to the y-axis. Alright? Then times sine theta. You get? So, in other words, what is force? Force is the product of mass and what? Acceleration. Acceleration times what? Distance, which is s, times what? Sine theta. I take it again. Work done is force times distance, right? Is that not correct? Correct. Then times the angle inclined. Work done is also 4 equals mass times acceleration, because force is mass times what? Acceleration. Here you have the distance and sine theta. I cannot say that work done is equals, sometimes you may not be given acceleration, so you'll be expected to use mg. G is what? Gravity, then sine theta. So this equation what? 1. I believe you are following, right? However, work done through the x-axis, which is the horizontal direction, it is the same thing. That is force times this. Let me use F rather because of time. Force times distance times what? Cos theta. Isn't that correct? So I'll say work done is equals mass times acceleration times distance, then times what? Cos theta. Sometimes you may not be given acceleration, then you'll be expected to use acceleration due to gravity, that is 10 meters per second squared or 9.8 meter per second squared. So I can now express this as mgs cos theta. Alright, so that is what I have. Please, work done along the y-axis is given as this, but work done along the x-axis is given as what? This. It is very, very important. Now I said energy can be also, that is, please note that energy, torque, moment, and Boyle's law. Alright? Energy, torque, moment, Boyle's law, and work done. You see that? Energy, Boyle's law, torque, moment, and work done, they all have the same dimension, right? Their dimension is given as ml squared t minus 2, right? Because if I reduce the dimension of work done right now, which is force times distance, I'll get what? mlt squared, that's ml squared t minus 2, because work done is force times distance. Dimension of force is mlt minus 2 times what? Distance, which is what? L. So work done is equals m. L times L is what? L squared, then t minus what? 2. Of course, this topic has been treated already on my YouTube channel. That is the topic I took before this one. Alright? A lot of quantities were the dimension of lots of quantities were deduced. Alright? For a better understanding, just watch that video. If you know you're having issues understanding dimension, we did for magnetic flux, electromotive force, and what have you. Please, energy, torque, moment, work, and Boyle's law have the same dimension. Alright? impulse and momentum. Impulse and momentum have the same dimension, okay? Please take note of that. Thrust, Young modulus, stress, pressure, they have the same dimension. I take it again. Thrust, force, Young modulus, stress, they have the same dimension. Why these ones have the same dimension? Just watch the previous video before this one. You understand what I'm trying to say here, okay? So the next one is what? Power. What is power? So people say, this is my power. This is this is your muscle. You cannot see your power. Power is abstract. You cannot see it, all right? So please, what is the meaning of power? As a science student, you are asked, explain the term power. Power can be defined as the rate of doing work. Right? It is defined as the rate of doing work. Right? Power is giving us work done. It's giving us work done. Okay, let me rub off this first part. So I said that power means the rate at which work is done. And power is giving us work done over time, alright? Work done over time. And I also told that work done is force times distance over time. Alright? Then I also said that force is mass times what? Acceleration times distance over what? Time. You see that? Because sometimes you may not be given force. You know force is measured in Newton, alright? Force is measured in Newton. You may not be given force in Newton. They'll give it to you as what? Mass. To calculate in mass, you have to use this formula. But whenever it's given as Newton, you use this formula. Do you understand that? So please, power is measured in watts. The SI unit of power is watts. That is big letter word, W. Please note that whenever you are giving power in kilowatts, you are to convert. If power is given is in kilowatts, you must convert to watts by multiplying it with what? 1000. If power is given in kilowatts, you are expected to convert to watt in most cases by multiplying it by what? 1000. But to convert watts back to kilowatts, you divide by what? 1000. Kilowatts to watt, you multiply by 1000. Watt back to kilowatts, what do? You divide by what? 1000. Okay? Please take note of that. Now, there's what we call efficiency of power. Alright? The efficiency of power can be defined as the ratio of the work outputs, that is power output, sorry, is the ratio of the power outputs. It is the ratio of the power outputs to the power inputs times 100 over what? 1. It is the ratio of the power outputs to the power inputs. In most cases, you are not given the power outputs. The power output can be noted as what? PO, then power input PI. Okay? Now, for me to get the power output, since I wasn't given, I'm going to be using this formula, which is, I'll use this or this to get the power output. The power input is mostly given in the question, alright? Except you are asked to look for the power inputs. And you are not given the power output, of course, you have to use this formula. So please, this is the efficiency of power. This is the formula, and this is the formula of what? Power. Take note of that. It is very, very important. Now, please, we have two types of energy. We have potential energy. Potential energy, it is the energy possessed by a body at rest. Potential energy is the energy possessed by a body at rest, and is given as what? mgh. M is the mass, g is the gravity, Gravity, and h is what? The height. H is what? The height. Potential energy, I said, is the energy possessed by a body at rest. M is mass, G is gravity, and H is what? Height. What about kinetic energy? Kinetic energy is the energy possessed by a body in motion. It is the energy possessed by a body in virtue of what? Motion. That is the energy possessed by a stone launched into the atmosphere is kinetic energy. Type of energy possessed by a flying bullet is kinetic energy. Energy possessed by a body in motion, right? And of course, I told you that kinetic energy and potential energy are both scalar quantities. Kinetic energy is given as half mv squared. Kinetic energy, potential energy have their unit as what? Joules. Kinetic energy, potential energy have their SI units as joules, or they are measured in joules. Please note that power, I told you that the SI unit of power is what? Watt. If it's not measured in watt, it can also be said to be what? Joule per what? Second. Joule per second. Because power is what? Power is work done. Is that not correct? Over what? Time. And work done is what? Joules. Is measured in joules. And of course, time is measured in what? Seconds. If this idiot goes up, it becomes JS, that is Joule per second. Joule per second. If I don't express like this, I will express like this, like Joule per second. So please take note of what we've done right now. In our next video, we'll start solving questions on work, energy, and power. Always make sure you stay tuned. Subscribe so that when I upload a new content, you'll be notified by YouTube. Do have a wonderful day.